All right, welcome to this edition of Firefighting Fridays. I'm Jeff Diederich with Strategic Fire Training. Today we have Micah, Chad, and Jeff Shupe. We're going to hit the subject of water supply today, talking a little bit about the traditional approach, the reality approach, the book approach, and some of the things that the fire service gets hooked up on that really may not be helping us at the scene of a fire. So Chad, we started this conversation with you with the question you had, and then we quickly went into the weeds with Jeff. So
well, I think
let's start there.
I think the whole show came, my question was over tandem pumping, but I think this whole show came about from a question that Micah got sent into Strategic Fire. Right? Is that correct?
Okay. Yeah. The question that was brought to us by another firefighter here in the state of Kansas is he asked me, when we roll onto a fire scene, should the primary hydrant have two hookups on it? Well, I asked him what he meant. He said, well, we lay in for the primary, and then our procedures, our administration, they want us to hook on a 2.5-inch gate. So it allows other companies to be able to tap into that same hydrant. And I asked him, I said, well, what's your water supply like? Is the hydrant, are you using 5-inch? Are you using 3-inch off a 2.5 threaded hydrant? And what do you have there? And he said, no, it's just maybe you get 500 GPMs or 1,000 GPMs out of it, but they're wanting us to take a 5-inch Storts and also use a 2.5 gated water appliance. I was like, well, there we go.
So that's been going on for eons, especially down through the fire academies. And early on, the explanation I got was, well, it's there in case you need it, but it's really there to help drain the hose when the operation is over. And like, okay, so we're gonna take time and whatever effort to do that, when what we really need to do is establish a water supply quickly and hit the fire. So all right, Jeff, so there we are, book versus reality, and then this gets into the theory of it and why we do the things we do. So let's get started.
Well, probably. Can you guys all hear me okay?
Yeah, we got you, boss.
Okay, all right, good. Okay, like everything gets started with somebody in a conversation. Somebody goes to a school or a conference and hears somebody from another part of the country talk about doing firefighting a certain way. People take that home and think, hey, this is the way, because this guy's standing up in front of the people telling them and giving them the gospel according to firefighting. And we've said this, I don't know, 10,000 times already. Firefighting is circumstantial. And so this thing about, water supply and how you get water from the source into the pump, that's a local issue. But the other thing is, you have to understand your water system that you deal with. Are you dealing with a rural water situation where you're having tankers bring your water in? Are you operating from static water sources, or are you on a municipal water system, or do you have a combination thereof? Because I know we had a fire here in one of the cities in Northern Ohio years ago, a big city, about 70,000 people and several engines, a couple of truck ladders or truck companies in service. They had a huge fire where they were operating off the municipal system. And then other departments coming in on this big fire were operating at draft in a nearby water system or source, I'm sorry. And so it just goes to show you have to look at what you have to work with. So going back to what Micah brought up, I know Micah called me some time ago and brought this up, and we've seen, Jeff, and you hit it right on the head. We've seen departments that have had both 3-inch and 5-inch supply hose in the past. And it was like, what's the rationale? Well, if it's not a big building, we'll use the 3-inch supply. Okay. Or if the fire's not big when they get there, they'll use the 3-inch supply. Well, you're dealing with a lot of the unknowns. So after a couple of fires where they realized that, the 3-inch didn't supply their engine to where they wanted it to on this fire, and the fires got away and so forth, they said, get rid of the 3-inch, just go with 5-inch all the time, which to me made sense. Okay. The different diameters of LDH that you have need to be compatible with your operation. When LDH first came out in the fire service many years ago, 3-inch had been there for a long time, but then we started seeing 4, 5, and 6-inch being used out there, and a lot of people were going to that 6-inch because after all, that's an above ground water main. Yeah, it is true. Once you laid it and charged it, that was it. You weren't going to move it. Okay. And if you had other apparatus that had to come in and work their way around that above ground water main, well, again, it just worked against your operation. So you see, this is how things need to be thought out of in a deeper perspective. You know, when you're looking at water supply, how to get it from point A to point B at the pump. I don't know if I'm answering or leading us down the right road here.
I think you are, but let's get back to that, attaching the extra appliance to the fire hydrant. And
Okay. All right.
reasons for and against.
Yeah. Okay. So one of the things that my department did years ago, they brought the new hose in. They went with 4-inch for everything. We were a 3-inch department many decades ago for supply purposes. And in the early 80s, they bought 4-inch supply hose. Well, you know, a lot of people say, why aren't you using 5? Well, because of the circumstances, because of what we have to deal with. And besides, that's the way our engines operate. So you have to look at how many people you have in an engine, the water system that you have at hand, spacing of your hydrants, and you want to keep it simple. And that's one of the things that firefighting will teach you, is that you want to eliminate as many steps as you can. So when you get that engine through the fire building and you start stretching the line, you got water to that nozzle quickly, and that you want to keep water coming to the nozzle quickly. And if you need an additional attack line, or you got to revert over to a heavy stream attack, that your system will allow you to do that. We've all been through this, you know, like when we go out and we do our class with people. But we ended up with 4-inch line, and it made so much sense for what we did. And this is another thing that we never got into the gate valve on a hydrant, because you know, you only got so much water coming in, you have so many guys to deliver that water and so forth, and that's it. Again, spacing of the hydrants and so forth determine, you know, how long you want that layout to be. And so there's just a lot of things you got to think about. But this thing about attaching a bunch of gate valves to a hydrant after you got a supply line already hooked up, in some cases, all you're doing is taking time away from opening up that hydrant and getting water into that supply line so it gets to the pump.
Yeah, and for us, again, municipal system, we're not carrying hard suction. We don't use water thieves. We don't use humet valves. It's hooked to the steamer, get as much of that hydrant into that first engine.
Right.
The next water source comes from another fire hydrant.
Yeah.
Or it comes from a 1,000-gallon engine that might be coming from another station, where if we're in a tight residential neighborhood and a relay pump from another branch of the municipal system is just not worth it, it's just too far, we'd have another engine pull in next to the attack engine, and they would hook their large diameter discharge into our other intake, and we would have another 1,000 gallons to work with. And that hasn't gone wrong for us yet. You know, we're carrying 750, here comes another 1,000. Can't get a house fire with 1,700 gallons, that you've got some organizational problems.
Yeah, go on.
So setting that engine up with 2 intakes we've seen that across the country, where we've only seen 1 intake. Right. So that off the bat is hamstringing your operation. That extra 2.5 on a hydrant, I don't see it as an advantage. How much more water are you going to pull out of that 800 gallon per minute fire hydrant? I mean, it is what it is. And if you got a 1,800 gallon per minute pump sitting on that hydrant, how's that help?
Yeah, that was pretty much my answer to this gentleman, saying the same thing about well, what was the philosophy behind the thinking, and the answer was, well, we want to maximize the hydrant. Well, unless that hydrant is going to be supplying 1,500 GPM or plus, and our pumpers are at 1,500 minimum pump capacity, where are you trying to get at? So,
Well, again, see here again, what kind of a fire are you dealing with? And if you want to fall back on the old principles of where you don't put all your eggs in one basket, if you've got a major fire and you want to maximize that engine's pump capacity and get everything into that, well, what if it goes down? That means your whole show goes down. So that's why, like when we talk about standpipes, and people were kind of shocked when we first started talking standpipe operation and putting 2 engines on the Siameses. Okay. And if you don't have a Siamese, that second engine takes a line into the first floor outlet with its, adapter to provide that second water source, just in case.
Yeah.
Oh yeah. I think it's one of those things that, it may sound nice in a classroom and in theory, but in the reality of firefighting,
it's kind of down a different road, and it's a training issue, but I've seen departments that are so worried about maximizing their hydrants, and they do this and they pull one line off of that engine.
Right.
Yeah, right.
Okay. If we're going to maximize anything, let's maximize our engine. Yeah, you do need to have a secondary hydrant if you got a big fire, and you do need to have a different water source, and that's always safe. But they get so worried about the water supply. Let's focus more on the attack than the water supply. I mean, it's great. We got 1,800 gallons going to this engine, but we're only flowing 200 out of it.
Right.
No, that is true.
You're taking the time and the effort for your second and third line,
right,
between the engine and the hydrant, and not the engine and the fire.
right.
Exactly.
Okay.
and then the follow-up question was the definitions of the tandem pumping, relay pumping. We all know what drafting is.
Hang
So
on, Micah, before we do that, Shupe, do you want to pull up that picture to show what we've got and what tapping a hydrant, what it's gotten into? Or
Yeah, let's do that. Where can I?
All right, bear with us, fire engineering.
And there's a lot of examples out there of
Okay.
what's been called fully tapping a hydrant, and not to bag on people that are trying to do the right thing, but multiple 2.5 lines that end up Siamese back together
Into
through
the
valves.
5-inch line.
Just
Yep.
Why?
Yeah. The time it takes to put all those valves together on that hydrant
Yeah.
can certainly be eliminated if you just put the 5-inch line directly on the steamer outlet. Okay. Yeah. And if you're going to, like we were talking a second ago, have to maximize that engine's pump capacity. Remember, hydrants don't manufacture water. You can put all the different hose lines you want on that hydrant. There's only so much water coming out of that main. And while if you have let's just say 2 or 3 LDH hose lines coming off that hydrant, it may cut down the friction loss of the water because the volume will be spread out over those diameters of hose, but it's not going to increase the flow. So, unless you get everybody to stop flushing their toilets and turn their faucets off and direct all the water down the water main into this hydrant, then that's how it works.
All right, boss, can you stop sharing now?
Okay, I will do that.
God bless those guys in that picture.
That looks like it would take 30 to 45 minutes for me to set up. I don't even know how you would even begin.
And then that once again is critical, especially in the early operations, about getting water in a fire quickly.
And freeing up the hands of the engine driver. I mean, reality-based firefighting, 2 guys on an engine. I mean, we don't have the luxury of losing somebody doing all that work when we need that first 5 minutes, we all need to be doing 2 or 3 things to get it, to get things lined up and going the way they should.
No, in Zoom.
So are we, and that's one thing I think we also have to look at. When you talk about fire departments and their ability to get water from the source into the pump and how much water they want to get versus how many attack lines they might have to supply, many fire departments don't do forward lays. They send the first due engine right to the fire building and they'll start operations off the water tank. And again, I talked about the spacing of hydrants, you know, like where I come from, the hydrants are 250 feet apart. You've heard me say that also in the past. Go to an intersection, you got 2 or 3 or 4 hydrants to choose from. Okay. So that's the key about getting water started quickly, which may make a difference on the fire and its control.
Yeah.
And then the ability for the pump operator to hand stretch that supply line back to the closest hydrant. And a department that has SOPs and trains upon them where the second engine pump operator arrives and works with that first pump operator to get that line established. You know, it's a wonderful situation. When you see it working, it's just like boom, 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 and you don't lose a drop.
That's what we do. But I'm in a city. I'm in a city like you, where our hydrants are 300 feet apart. You know, you can see them, and you know, Murphy's Law doesn't come into where we're exactly 300 feet. We're usually about 100 feet from a hydrant,
Sure.
so it's nothing.
Nothing is set in stone.
Yeah, right. Our drivers can hand jack 100 easily, and then that second end driver comes in and immediately assists with getting water to that first engine.
Right.
And it kind of, you know, we're talking about this, and Shupe, I've heard you say this thousands of times. Just keep the firefighting simple.
Exactly.
And it goes with water supply.
Right.
Keep it simple.
It's kind of funny because, like we said, also, if you add steps to your system, then you add the greater likelihood of complexities that can cause a failure somewhere down the line. Okay. I've seen one of those gate valves attached to a hydrant one time, many, many years ago. The one that you see being used on deck guns now,
Mm-hmm.
it actually broke and shot off, you know, and the water, what wasn't going through the other supply line was coming out that gate valve, and it caused the hydrant to be shut down. So, you know, these, like I said, add steps, add complexities, add the chance of failure. So keep it simple.
I think if there was more of a concentration on the having redundant water supply versus how do we put all our eggs in one basket,
Right.
it's actually more simple. I mean,
Oh yeah.
you know, if that engine has 2 intakes and it's already attached to the hydrant, another engine could hook into them and then lay out to another hydrant and pump in. Okay, now your attack pumper has 2 water sources going into it, if that's what you need.
Yeah, exactly. Yeah.
It is, and it's just as simple.
If you're from a small department or a rural operation or wherever, and you have other fire departments that you're going to work with, mutual aid, automatic aid, or whatever, this is where meetings ahead of time with those departments. Chad, you got a zillion fire departments down your way. You guys got to all meet together ahead of time to say, hey, we got this size hose and these kinds of couplings on our supply hose lines. Okay. What water systems are you guys on down there in your area, Chad?
Meaning like,
Is it just one water system?
oh no, every city has their own water system.
Really? Okay. Well, see, there you go.
Well, I mean, like the Quad Cities, I don't know where Coppell gets theirs from. Most of us get our system from Dallas County, and it gets shuffled around, but each town has its own pump system.
So it's not like it's the city of Dallas water system.
It's Dallas County. So
Dallas, okay, fine. So
they
that's
fill up our big tanks and our water towers with that. Each town has their own pump system.
well, that's why standardization is key.
Yeah.
You know, meeting ahead of time and saying, hey, this is what these departments need to work with for their supply lines and so forth. And this is what we expect from our engines. There was a thing many years ago, and I think it was called CAFERS or something like that. CAFERS or the idea was that many fire departments, I think they were down in the Oklahoma, Texas area, the officers of these departments met together, even though they were from a couple of different states, they met together to design apparatus based on their systems approach. And that's something that many departments or many people in our job don't realize, that firefighting is a systems approach. If your systems, like for example, the water supply system, if you got different threads or different types of couplings, for example, back home, we have threaded couplings on our LDH and they work great. We had snap tight or quarter turn or European, yeah, Storch couplings for a number of years. And going to the threaded, I gotta say, it was a great move, you know, and so they work very well, and they're very secure. Nobody else has got that, I know. Jeff, you guys run that out there in Bedford?
No, we've been on the Storch since we went to the large diameter, and but the issue of Cleveland was raised, and we went right to locking Storch couplings. Oh yeah. Because we had heard, you know, the horror stories of the twist, and they come apart, and if it wasn't the sideboard on next to the pump, it was your leg. I mean, for the longest time, my department, there's still some hang-ons to this, where their initial intake plug into the engine is always on the officer side because of the horror stories of a guy getting his leg broken by a Storch coming loose. Yeah. So that still lingers, even though we've had locking couplings forever. Yeah. So to your point, that first generation without the lock on those Storch was an issue. That hose had to be flat in the street, and it could have been curled up around the corner, and you didn't know it. As that water came, it brought that twist.
Oh, yeah, that was like a corkscrew coming down the street at you.
Yeah.
And
you had a 50-50 chance. If it was twisted one way, it just got tighter.
You're right. Yeah, you're right.
Then it come off.
And you see it coming, you just start, oh boy, you just kind of start walking away from it like,
You see, that's that history of the job that people need to know. How did we get to this point of locking couplings or going threaded couplings or whatever? And it's because of those previous incidents and we're not the only place that experienced that. I'm sure there was a ton of others, you know, across the country. But
even with the locking ones, it happens down here, and you can see it coming, and you're like, oh dear.
You hope it holds.
You just hope it holds, and you hope it doesn't hurt your engine.
Yeah.
You're like,
yeah, for sure.
I don't want to do paperwork on this.
Yeah.
I was thinking, Jeff, with the Quad Cities, we have one city that has a different style Storch. They have a 4.5 instead of a 5. So we have to have an adapter in our bag. And if we go to that city, we're threading on an adapter, and then we're Storching it. So
I was going to bring that up. Glad you brought that up about, you know, you're going to have to buy adapters. If we're really concerned about the cost of putting the fire companies out there, minimize the cost by standardizing once again, rather than having to buy a whole bunch of adapters. Minimize the cost by saying, this is the plan that we'll use, you know,
and that's hard to do because, you know, with water systems and hydrant systems, that's done way before any of us got there.
Right.
Truthfully.
Yeah. And it was, you know, as foundries grew with the cities, I mean, that's why there's over 350 different 2.5-inch thread specs in the country.
Yeah.
Because each city had their foundry, and like, oh, well, we're going to make our pipes. Yeah. Well, we'll make them our thread.
That's right.
You know,
or some, you know, oh golly, there was fire departments out there. 2.5 is what we know, right?
Yes, sir.
So we come in. Well, when you do your history reading, you come across 2 3/4 inch, you know, or an actual 3-inch threaded coupling. It's like, wow. And you know, it's
always local
process. Yeah, exactly. So,
always local.
Okay.
So if I could redirect you
yeah, go ahead.
Back into that issue, adding the appliance on the hydrant for us in our experience is just not worth it.
Right.
If you're having trouble picking up your hose after the fire and you need that 2.5 gauge on there, there's just ways to train around that. You know, you
There
just got to
are.
know how to do that. I'm sorry, but
Can't you? I mean, I'm sorry. I didn't know that was the issue, and that I've never heard that's why they were doing it.
It's an
Can't you
expensive
just-
way of draining a hose.
yeah,
Can't you just turn off the hydrant and very carefully open the outlet on the side? I know it has the chance of flying off, but
Yeah.
if
you
you
know,
open,
it depends on your intake valve. There's ways to drain it right off the intake valve. So I mean,
yeah, it may take a little bit, but I mean, if
Well,
that's why we're doing it. We're
yeah.
not.
When somebody tries to justify something like that, and that's what they're going to use,
right.
you know. So
So, you know, to the point for our group, put your time and your effort into getting water to the engine as soon as possible.
yeah.
And it doesn't take very long.
If it takes you a few more minutes to figure out how to drain your hose at the end of the fire, okay, you got time to do that.
So we haven't got the fire out yet, but we're already thinking about how to drain the water out of the hose.
Right.
Oh,
And then to get in, we've covered a little bit about, I mentioned that, you know, the nurse engine where the second engine just dumps its water tank into the attack pumper.
Yeah.
Talked about, you know, laying out to another hydrant from a second engine to supply the attack engine. So let's put the relay pumping philosophy act or the art and put that into words for everybody here. So tandem pumping, two pumps running in tandem using the same water source to attack the fire. So Jeff, I think you're going to have the best way to explain this where
Okay.
we can all kind of get it in our heads.
You want me to?
Chad's
You want to
shaking it off like,
nope.
Huh?
okay. Chad's waving it off. He doesn't want to talk about it.
You
So
wanna
it's
talk
okay.
No, I want to talk about it. I think we
Oh.
need a good explanation, and I don't have the capability of giving that.
So you want to hear the same thing we talked about before we started?
Yeah, let's have it. Let's have
Yeah,
that.
the part where I
read.
said stop, we need to record this.
Okay, all right. Yeah, okay. So my experience with that goes back to the 70s. And I learned from a gentleman by the name of Parker Brown. And as I think I've talked about him before, he was one who designed the turbojet nozzle for Akron Brass. This guy's mind was just, he was a hydraulics genius, okay? And he's still around. He still lives just a few miles away. And every once in a while, I give him a call. He demonstrated tandem pumping for this group. And if you actually see tandem pumping, and again, I'm going to give you a simplified version of what I remember from back in 1970, well, whatever, in the 70s. Okay. That's the way he did it. So you got to remember all this stuff that we're talking about has evolved from the past. Gasoline engines, standard transmissions, rotary gear pumps becoming centrifugal pumps, things like that. Okay. Older cities now were newer cities at one time. You see where I'm coming from? So their water systems might have had hydrants sitting on a street corner in a downtown area because you had a 48-inch main where they could put a couple of engines on a hydrant. If you take a look at the older cities that used to have the high pressure systems, you know, like for example, Cleveland was one, Detroit was one, Toledo, Philadelphia, they all had high pressure systems, which drew water from that big river or that big lake out there. And they would pump from the high pressure station through the water mains. It was a separate fire system. Okay. So we have a major fire. And he set this thing up. We had a hydrant that was very adequate. Okay. And it was explained that first engine comes in and hooks up to that hydrant. Remember what we're talking about? With hard suction.
Right.
Okay. You don't see those anymore. And let's say that engine's got 3 2.5s running off it. And this fire is big. And we need more water. We need more tack lines, maybe even a master stream. And with 3 2.5-inch hand lines going, and you got a residual of 70, we got plenty of water left to give to a second engine. Remember, there's something here that doesn't get mentioned in all of this stuff. The strategy and the tactics. Because what you're doing is putting 2 engines which are going to have a lot of pumping capacity, are going to be able to deliver a lot of water from one location. So if this fire is in a big factory, and a factory is 2 blocks long, like we've seen here, and that you're going to stretch all your lines 2 blocks down the street. Well, okay, let's get back to, again, strategy and tactics. Is this a smart thing to do? Anyways, this is what they used to do. So the first engine comes in, hooks a hard suction up. They get 3 2.5 hand lines going off this hydrant. Then another engine comes in. Okay, we're going to do tandem pumping. We get this second engine ready, and they get their hard suction hooked up. Okay, now we go to the hydrant and we start turning the hydrant down while pumping to those hand lines. All right.
Ross, real quick. So hard suction from the hydrant to the first engine, hard suction from the engine to the second engine.
Yes, sir.
Okay, just
Yes, sir.
clarifying.
That's exactly. And I'm glad you brought that up, because again, when you're talking soft sleeves, as they used to call them, soft sleeves had a tendency, once the water starts going away from it, what to do. You ever seen it actually suck down? Yeah.
Sure. Yeah.
Because you ran away from your water. So that's the whole idea behind hard suction, is that when that engine is actually drawing, anything, that probably should, that's why we have residual pressures that we want to maintain. That hard suction prevents that from happening. All right, so first engine is hooked up with the hard suction to the hydrant. Lines are pumping, and now we start turning down the hydrant. And as Parker was directing this operation, he says, when we start getting down to 10 on the residual and we start going below that, okay, now we can take the steamer cap off the initial engine. And son of a gun, if you haven't seen it, it's hard to believe, but you're looking at intake, there's that water going right around. Okay. And that way you're able to put that new suction from that second engine right up to it. Okay. You got it hooked up, ready to go. Now we open up the hydrant again fully. You've heard us always talk about opening hydrants fully, no matter how big the fire is, no matter what size supply line you have. Always open your hydrants fully, get the full benefit of their volume. And now that second engine, and again, this is that thing about reading gauges, okay? So that 70 on that first engine is now gonna go, all right? But whatever water they're not using is now gonna be directed to that second engine.
So funny how, as the fire service evolved and tandem pumping became this ghost in the fire service, is it because the reason why there was relay pumping was because there was only a few discharges on the engines back then?
Yeah.
And those were not large diameter discharges. So the modern version of that now would just be to use your large diameter discharge, push that into the second engine, and then now you're using all the water that you can, because now our pump capacities on our engines are 15, 1800, 2000. We can do that amount of volume without being in tandem anymore. Does that make sense to you, Jeff?
Yeah, absolutely.
So for me,
So
I've been in the jobs since the mid 90s, and tandem pumping was something that we had studied and talked about, but never done it on the street, because at that time the pumps were just getting that much better, and it didn't become something that you had to know how to do, because it didn't make sense to do it anymore.
It's like the pressure governors on pump panels now. Those are going away.
Yeah,
we're getting to a generation of firemen that don't know what that is.
Jeff, you just brought up a real good point, and that is the number of outlets and the size of them. Unless it's changed right now, a Class A engine by NFPA standards, what's the minimum pump capacity that can be put in that engine, that brand new engine that you're going to pay $600,000 or $700,000 for, and still have it classified as a Class A engine?
I'm not sure what the number is. I'm guessing it was ridiculously low.
Yep.
Is it like, I'm going to take a guess.
Go ahead.
I want to say like really low, like
500,
500 is what I was
You guys
going.
are close, 750.
Dang it.
750 gallons per minute was the Class A or is the Class A rating.
Yes, yeah. And it's just like the size of the water tank. You know, you can get away with the 300-gallon water tank on a full-size, honest to gosh, NFPA Class A engine.
And
This
they
is what,
they reconfigured that to 300 to take care of the country's desire for quints.
exactly. At the
Sorry.
expense of the hose beds,
Yeah,
which we
Yeah.
talked about last episode.
yeah.
Oh, golly, it's all intertwined, isn't it?
So yeah, everything touches everything.
yeah.
Just like trying to build an engine. I mean, you can't make a change here and not affect something over there.
Right.
So Jeff, I want to go
Okay.
back to the tandem versus relay. So tandem, intake to intake. Relay, but with hard suction. Relay is discharge to intake. Just to
Exactly.
clarify.
Now, here's another thing that needs to be taught, and it has to be done properly. And that is when you're setting up a relay, your biggest pump goes to the source.
Yes.
Okay. You can't, it's not going to work if you take, once again, an engine with either 750 or 1,000-gallon a minute pump, put it on a source like a hydrant. Okay, you got a good hydrant, and then you're going to supply the engines 700, 800, 900 feet away with this LDH, and you think, oh God, it's not going to make it there. And you want to supply with them pumping and maintain their residual at 20 psi.
And something we were
It's a
talking
bit more
about,
complex, and that's why when you get into relay operations, you need a control officer.
something you didn't talk about, or we talked about before we started recording, was that when you do any of this, there is a driver at each engine. There
there
is an
should be.
engineer, and
Right.
it has to stay there.
I think that it would benefit the fire service if they're not keeping their engine operators with the engine at scenes, they should have a damn good reason for that.
Yeah.
If you're dealing with just a standard residential house fire, having two people making sure that the water source is established, running, and things are being accounted for on the outside. I think those are the guys showing up. They're not dressed. They should be conspiring to make sure that water source is secure. The kinks are out, that things are happening that need to happen from the engine to the door.
Look, a bread and butter operation, house, okay? 1 or 2 rooms going in the house. You got a line going in, you got a second line that's probably going to be stretched and so forth. You need 2 pump operators to assure that you'll get water to those lines and you won't run out. Absolutely. And many fire departments, it's like we have people who are so worried about the nickels and dimes and the cost of putting a fire department out there. They don't realize the importance of why we do these things, why we need 2 pump operators. Again, touching on that standpipe operation, 2 engines pumping into a standpipe system, just in case. And that takes 2 pump operators also. Jeff, remember when we did the standpipe class in your department years ago?
Mhm.
And I threw that question out there. How many pump operators does it take to get water into a building?
Yep. Only
And-
the guys with some whiskers on them said 2.
Yep. So,
Great.
but yeah. Well, yeah. No. Okay. How are we doing so far?
We only got a few more minutes, but I wanted to hit some of the other scenarios that come up with
Yeah.
water supply, and that is driving over supply line
Don't do it.
where you're trying to get other apparatus into place. Now, most fire departments, in my experience, that maybe don't see a lot of fire, they generally have a spoken rule of never drive over a charged line. If you look around to fire departments that do the business on the regular, they drive over the supply lines on the regular. And what I've understand is as long as it's only one wheel at a time and it's slow, it's going to be fine. Jeff, what's your experience with this?
Yeah, when you see that, you cringe because of
Yeah.
what you've been taught. Never drive over a supply line. If a civilian in a car drives over a supply line and there's a police officer nearby, that guy's getting a ticket. And is it hypocritical that we're taking this big, massive fire truck to drive over a supply line? Again, I hate to say it repeatedly, but what are the circumstances? But we can
right,
do it. We can do it. And whether it's one wheel or two, and if you're going to do it and you have any question about it and it doesn't break the line, okay, take the line out of service after the fire and inspect it. See if there's any abrasion to the jacket, So that's the other thing about LDH. Are you running rubber line, rubber covered, or you're running rubber line jacketed, double jacketed hose with big thick jackets, so forth. So
I think the real threat there is the water hammer issue. If you're moving a lot of water and it suddenly stops, there's a chance of that doing some damage to the system.
I think we've all seen the video of the car, the privately owned vehicle driving over a fire hose, a supply line. And it wasn't so much the weight of the car or anything, but it was a jagged metal underneath the car because the car is closer to the ground. Hell, the engine, my God, we can crawl under the engine and not come, close to anything on the underside of it. But a car, you got bolts, you got pieces of metal that are hanging down,
Right.
and that can cause a hose line to be ruptured, punctured,
Sure.
or whatever. So,
Sure.
Yeah.
Just wanted to hit that little tidbit because it obviously it's happening every day across the country where another apparatus needs to get in place.
right.
And there's a supply line down, and
Yeah.
it's not something you want to make a habit of, but
Right.
understand that if it needs to happen, it should happen.
Right. One thing I want to hit upon, and that is, we talked earlier about our water systems. Guys, you got to know your hydrants. I come from a department, a city that its water system is far outreaching. Cleveland Water, they put water all over Northeast Ohio. They got that big thing called Lake Erie out there, and they just keep drawing it and putting water on out there. When you have different styles and manufacturers of hydrants on your system, you may have a different number of turns to get those hydrants completely open. But keep that in your mind to know your hydrants and know the amount of turns to open that hydrant all the way. I don't care how small the fire is. You always open your hydrants and the pump intakes all the way. And I think maybe that's a fear of a lot of people, because I've seen it done. I mean, we've all experienced it. A lot of times I want to scream and say, you know what, this isn't just us. This is something that we have heard from people across the country having these same issues. And that is, they get excited. We hook the line up and turn it on 3 or 4 or 5 times because water's starting to come out. And really the hydrant is more than halfway closed. And the guy's running down the street thinking he's got to do something else. No, focus on getting that hydrant open all the way, then come down, and your pump operator can then open up his intake all the way. So like I said, when you hear about these failures of the systems to supply your engines, maybe that's one of the issues that we need to be aware of. Okay.
Yeah.
Very good.
All right. We've covered the waterfront, pun intended. Here we've talked about the attaching extra appliances to our hydrant. Talked about different ways of laying out, supplying that attack engine, the difference between relay pumping, tandem pumping. Some of the things we've noticed in our experience over the years. Chad, you got anything else that you want to throw into the mix here before we close it up?
Water. I mean, guys, I'm blessed. I fully big city, all urban, good hydrants, good water. I think we covered a lot of stuff, a lot of history of stuff today, and a lot of terminology. And I think that's a lot of the problems. It's a different terminology across the country, but keep everything simple. It always works.
Yeah.
Yep. Jeff, I know you probably have like 10 other things you want to throw in here.
Yeah, I do. And I don't know if it was you or Micah that brought it up, but here's that book, Harold Richmond. It's an old book, and it's got another edition out. I think someone rewrote it. I can't remember the guy's name, but he brought it up to date. Anyways, Harold Richmond wrote this book years ago. He wrote one for engines and one for trucks. tremendous information in here that is still relevant and always, to me, always will be relevant to the fire service. So whenever you guys have heard me talk about 5, 10, 20, 3, 2, 1. Guys, if you get this book, okay, all right, like I said, it's old, but anyways, Harold Richmond, go to page 58. And he talks about reading the gauges, okay? And right here they're talking about, you know, the drops in pressure from static to residual with like one line flowing and how many lines you can supply after that by reading your gauges and then looking at your compound gauge to see what's left on your residual. And that's the thing, you know, about understanding, you know, how much water you have in a pump to supply your attack lines. Remember, you can't expect one engine to do it all. And I got to tell you, I think I mentioned this before also. I was down in the Beltway area years ago, DC, and I was following an engine on the Beltway. I don't know where it was from, so I'm not pointing the finger at anybody, but it was kind of funny. And I thought, well, you got to look at this. I think they had 11 attack lines on this engine, you know, and it's like,
Yeah.
wow.
Yeah.
Where would you get the water to supply 11 attack lines? You know,
I think it's just,
What if they're only
just,
100 gallons apiece?
well, no, it's just you get
Not
your
even.
choice. You
Yeah.
have your choice. You can take that one or take that one or
right.
take that one.
And, you know, we talked about the old fire service too. Remember with 2.5-inch supply lines,
Yeah.
you know, 1, 2, or 3 blocks long. And you were going to be expected to supply that booster line.
Yeah.
And then we graduated from booster lines 3/4 inch to booster lines 1 inch. And then we got into 1.5 inch, 1 3/4. Man, are you crazy? But you know what? We needed to do it. And just like one of the previous episodes that we had recently about talking about, you know, tip size and volume of water and things like that. This is what we're all about. Taking as much water in there with you as you can to kill the fire. Don't play with it and don't think you're going to, you know, punch a computer and figure out all these formulas and numbers and things like that. And that's going to go help you put the fire on. It's water, overwhelming force.
Yeah.
So,
All right. So the other publications for water supply, the Shepherd book, Casey's book.
Yep.
If this is something that you really want to get deep into and have a solid understanding, it's been written down. It's there for you.
there's Casey's right there. Okay.
Yep. Great book.
Fire service hydraulics. And here's another one. We've always mentioned this gentleman's name.
William Clark.
Yep. This
There it
is the second edition right here also. He does a lot of talking about engine operations in there too. So, all righty.
These are the reference materials you should be looking into. So when your officer calls you on the radio and says, "Can I get another line off your engine?" You should be able to look at those gauges and say yes or no.
And sometimes no is okay.
Well, yeah, that's why we're asking.
Yeah, no
Trying to
is an
plan here.
okay answer.
Yeah.
Uh,
All right. Well, I'm feeling good about the last hour, Jeff.
Yeah, me too.
Thanks everybody for tuning in. We'll see what we can come up with for the next month here. So hit us at strategicfiretraining@gmail.com and send in those questions or comments. Chad, you got something?
real quick, yeah. Hey, Washington, we are coming that way in 2 weeks. or 3
Olympia.
weeks. Olympia,
3 weeks,
Washington.
3 weeks.
We will
yeah.
be with the Southwest Washington Fools doing our 2 days
Sure.
class. I think it's already sold. It's been sold out for a while. There is a waiting list. And I'm pretty sure they're going to organize something where you can come out and we'll do a little meet and greet and we'll answer questions and come hang with us if you're in the Washington area.
That'd be good.
Later
And
on
then-
next month.
And then that's October 9th, 8th and 9th in October. And then I think the 24th and 25th or the 25th and 26th, we are doing a private class with Waco Fire Department, and we're really looking forward to it. So we get to touch their whole department in 3 days.
It's going to be wonderful.
Yeah.
All right, guys. I hope everybody has a safe and
Give us a call.
But-
Love to
pleasant
come out and
day.
work with you.
yeah.
We would
All right,
love to
everybody,
come out
take
and
care.
work with your department. So, okay.
Cheers.
Okay.